going to continue doing AP review. This is 2009 Form B, AP NBC, free response number 5. Let f be a twice differentiable function defined on the interval from negative 1.2 to 3.2, open interval, with f of 1 equaling 2. Sorry, I should add that here somewhere, that f of 1 is a 2. Cool. The graph of f prime, the derivative of f, is shown here, better on the actual AP than on my terrible drawing. Here are the important highlights. The graph of f prime crosses the x-axis at, sorry, these are not endpoints, it keeps going. Sorry, my bad. At negative 1 and at 3. And this graph of f prime has a horizontal tangent line at x equals 2. Let g be the function given by g of x equals e to the f of x. All right. Part A, write an equation for the tangent line of g at x equals 1. Okay, so part A, we want a tangent line for g of x at x equals 1, right? Okay, so anytime in all of math we're asked to find an equation of a line, we need two things. Number one, we need a point, right? That point needs to essentially give us x comma y, right? So we know x is 1. And we don't know the y value, right? But the y value should be g of 1, which we can find, right? G of 1 is e raised to the f of 1. Well, we were given f of 1 is 2, so that's e to the second. So I now have my x comma y, right? Before doing anything else, I have a point. The second thing I need anytime I'm asked for an equation of a line is a slope. But the slope in this situation, because we're looking for a tangent slope, is just g prime of 1. So we need to find g prime of 1. Well, that's going to mean we need g prime. So if g of x is e to the f of x, then g prime of x should be the derivative of e to the stuff, which is e to the stuff, times the derivative of the stuff. So e to the f of x times f prime of x. So g prime of 1 should be e to the f of 1, which we actually already found up here, times f prime of 1. Well, I know f prime of 1. It's the only f prime value, only non-zero f prime value that I have. So my g prime of 1 should be an e squared times a, sorry, that's a negative 4. I just am terrible at drawing things, times a negative 4. So I get that my tangent slope is negative 4e squared. So I now have a slope. I have a point. Both of them involve e's, but hey, life's hard, wear a helmet. So my answer is y minus the y value, which is an e squared, equals m, which is negative 4e squared, x minus the x value. So if they do not tell you to solve for y, you're great. That's a totally fine answer. There's a tangent line. That's the equation of the line. If you want to play it safe and solve for y, the easy way to solve for y is to just add the e squared over and not mess with any of the other stuff. Right, so that is also totally fine. I would not suggest distributing the negative 4e to the e to the second. Cool, there's your answer. Let's talk about B, if I can figure out where I lost my eraser. All right, cool. Sorry, you're getting 3 points for that question. You're getting 1 point for finding g prime. You're getting 1 point collectively for g of 1 and g prime of 1, right? So that's worth 1 point collectively. And you're getting 1 point for your answer, right? So 1 point for finding the point and slope. You got 1 point for the derivative of g, 1 point for the whole answer. Okay, cool. Let's keep moving. Part B. For that same open window from negative 1.2 to 3.2, find all values of x at which g has a local maximum and justify your answer. Good times. All right, so we need to start by translating what this means. So on this window from negative 1.2 to 3.2, right, which is the only window we have, open window, we want the x coordinates, right? I believe they only said x coordinates. Hang on. Yep, x coordinates of g of x local maxes. All right, so we want to know where g has a local max, right? That's what we're trying to find. That's the question we're asked. So if you're asked for extrema for g of x, you need a g prime of x sign chart, right? That's the best way to do this. So I need a g prime of x sign chart. Specifically, I need, if I want a max, I need g prime to switch from positive, which would mean g is going up, and then g prime is negative. Hey, look, g is going down, right? So if I want a max, I want g prime to switch from positive to negative. So let's go back to the formula we found for g prime. We said that g prime of x was e to the f of x times f prime of x, right? Well, that's great because here's the cool thing. E to the stuff is always positive. It's not 0, it's not negative. This guy right here, no matter what the stuff is positive. So essentially, a g prime of x sign chart is really just an f prime of x sign chart times a positive thing. So if I want to find the critical points, the only critical points are going to happen when g prime equals 0. G prime doesn't exist is not a thing that's going to happen because f prime exists everywhere on here, as does f, and e to the stuff exists. Or it included endpoints, but we already know there aren't included endpoints because it was open. So if I want when g prime is 0, I really want when f prime is 0, since we said that this guy can't be 0. So I know the two spots where f prime is 0. The two spots where f prime is 0 are here and here. So my only critical numbers are at x is -1 and x is 3, right? Those are my only critical numbers. So now I can make a sign chart. And you can do it by visual inspection too because you are given a graph. But remember, this is the sign chart that matters. These are the signs I care about because this guy's always positive. So whatever signs this has, it's the same signs that we're going to see for g prime. So if I look at my g prime of x sign chart, right, g prime of x has two factors. It has an e to the f of x. So we'll start at -1.2. My critical numbers are -1 and 3, and my end is 3.2. And the other factor is an f prime of x. So I'll inch this up a little so you can see better. So I know that e to the f of x is always positive. I know that I can see by visual inspection that here, before -1, f prime is physically above the x-axis. Since that's the graph of f prime, it's positive. I can also see that that's true at after 3, but in the middle, between the two zeros, from here to here, I seem to have a negative f prime because it is below the axis. So what I'm getting is that g prime is positive, then negative, and then positive, which means what my g is doing is going up, down, and up. Since this is an open endpoint, right? This is an open endpoint. Although this would be a max, it's not a candidate. And the same thing with this. This would be a min, but it's not a candidate. So the only candidate for max is when x is -1, and that's the only local max. So the only local max is at x equals -1 when g prime of x changes from positive to negative, right? So in terms of your answer here, you're getting 2 points. You're getting 1 point for the answer, x equals -1, and you're getting 1 point for the justification. All of this counts as the justification. They did not say explain your answer in words, so there's a solid chance that this would be enough justification because explain usually means words, justify can mean use tables. All right, let's do part C. Part C. The second derivative of g is given by a big ugly monstrosity that I will write down on the whiteboard in a second. Is g double prime of -1 positive, negative, or 0? Justify your answer. So they give us the second derivative of g, which is a real nice solid of them. Like, they didn't make you find it. So they give you that this second derivative is e to the f of x, and then in parentheses we get f prime of x whole quantity squared plus f double prime of x, end the bracket. Cool. Now, they asked us specifically about g double prime of -1. So that means e to the f of -1, and we'll talk about that in a sec. And then we have f prime of -1 whole quantity squared plus whatever f double prime of -1 is. Cool. Okay, so all we're asked is this positive, negative, or 0? We just care about the sign. So first thing we know is that this guy is positive. For the same reason that we discussed him being positive before, e to the stuff is always positive. It's not 0, it's not negative, e to the stuff is positive. The only way that e to a power can come out negative is if you put something in front of it like a -5. -5 times e to the stuff is a negative because -5 is negative, and you multiplied it by a positive thing. All right, let's talk about what other stuff we know. F prime of -1, right, is, so if we look at -1, f prime of -1 is a 0. Right? This guy, right? This is just the y value on the graph, right? The graph is f prime, so it's a 0. So this guy's a 0 squared. Cool? All right. So all of this, the entire problem hinges on if you know the sign of this guy. Well, remember that f double prime of x is the slope of f prime of x, right? Because it's slope and derivative are essentially synonymous if we want to use a way oversimplified version of things. So if I look at -1, this thing has a negative slope. It is angled downward, right? So f double prime of -1 is less than 0 because at x equals -1, f prime of x is decreasing, right? It's going downhill. It's decreasing. So this guy is a negative number. I don't know what number, but I know he's negative. So I get that this is a positive number times 0 plus a negative number. That's a positive number times a negative number. Yo, that comes out negative. So the answer is g double prime of -1 is less than 0, right? The answer is it's negative. All right, it's negative. And what they said was justify your answer. So there are any number of ways to justify it, right? But the short answer is that at around -1, f prime is decreasing, so f double prime of -1 is less than 0, therefore it's negative. Again, it's acceptable to justify that e to the stuff is positive. All right, cool. Yeah. Last bit. Find the average rate of change of g prime, the derivative of g, over the interval from 1 to 3. Cool. Okay, so average rate of change just means old school slope. So if I ask you to find an average rate of change, all right, swear I had a different color somewhere. All right, cool. Anyway, average rate of change, when you hear average rate of change, that's just old school slope. So if you want the average rate of change of g prime of x on the window from 1 to 3, you just want to do g prime of 3 minus g prime of 1 over 3 minus 1. Old school slope. And that means we're going to have to find some numbers, right? So we're going to have to figure out that this is e to the f of 3 times f prime of 3 minus e to the f of 1 times f prime of 1 over 3 minus 1. Now, you might be having a moment where you're like, oh crap, I don't know one of these numbers, and that's okay. You should be. It's cool. We don't know this, and that's kind of terrifying, and you have a bad moment. But then you realize that f prime of 3 is totally a 0. This guy is a 0. So it's irrelevant that I don't know this number. I know this is a non-zero positive number that I can't think of, but it doesn't matter because this number is multiplied by 0. So I'm going to get 0 minus, we've already done g prime of 1 before. We've done g prime of 1 like at least twice, maybe. We got -4e to the second, right, over what seems to be a 2. So I think we get 2e to the second. And that's the answer. So again, what they wanted here, you got 1 point for this, which is called the difference quotient. Old school slope is called the difference quotient. Things in math are named either after a person or after exactly what they are. This is not named after Mr. and Mrs. Difference quotient. It is a difference, subtraction, and it is a quotient, division. It is the division of two differences, hence difference quotient. And yeah, so, and then the answer, to actually get the answer, that was your other point.